Hello, good afternoon all. My name is Sairam Shetty, and I'm working as team lead EDA here at GSAS Microsystems. In today's webinar, we are going to discuss about the importance of understanding the PCB fabrication process. During the presentation or during the demonstration, if anyone having any questions, you can please type your questions in the chat. And also, just let us know if you have any difficulties we are experiencing while uh, completing your designs and delivering to your fabricator. Just let me know if you have any difficulties. I like to address their queries as well. Now, let us get started. Today, our agenda is about options for delivering the data to the fabricators. And also, we're going to discuss about the pros and cons of PCB file and a Gerber. And we're going to discuss about the fabricator view of your design and how you can maintain the control of your design data, followed by demonstration. And we'll be taking your question and answers. Let us first talk about the what are the options available for delivering the data to the fabricators. Here, there are three primary ways to transfer data to your fabricator. We can email GIF files or complete a form on a paid PCB vendor's website. Again, Reachway offers a newer, innovative way whereby the designers can simply share the bare board fabrication files directly with a couple of clicks. In addition, the release package can be shared with the fabricator early in the process, and the design can be viewed within a browser without loading any software. And now let us discuss about the pros and cons of the PCB file or Gerber. There are two primary formats for delivering the PCB design data for fabrication: native design files and the Gerber format. Let us take a look at the advantages and disadvantages of each. If you look at the PCB file, the advantage is easy of use for the designer. And when it comes to the disadvantages, manufacturer requires the same software where the designer uses to review this, and a technologist with knowledge of software is required. Contains too much information, there is a possibility of data corruption if you share your source PCB file for fabrication. And what is the pros and cons of the Gerber file? Gerber file is an international standard. Transfer the necessary minimum information, control over the file generation process. We can compare the original file with the modified file from the manufacturer. It is more difficult for the manufacturer to make mistake if you share the Gerber, which is the first point itself is a international standard. And the cons Gerber is we have to share some information in the form of stub files, and advise a little customization of the export depending upon your project. They are the pros and cons when with respect to the PCB and the Gerber. Now let us discuss about the fabricator view of uh, your design. The primary feedback from the fabricator will typically focus along layer stack design and the placement and routing of your board. The first one is the level of technology standards you are used, materials used, compatibility of the materials and the structure, calculate different values of the transmission rates. For some reason, design may be shortcomings which the manufacturer will consider as a mistake and offer to make required adjustments. They are the steps, things the manufacturer will be verifying while when after sharing the Gerber with him. The fabricator may suggest a change to the layer stack in the case where the dielectric materials, dielectric layers have been incorrectly selected in attempting to reduce the overall thickness of the board to achieve performance objectives. The designers may specify pre-pack layers that are too thin. Often designers forget that the conductor layers themselves have thickness and that thickness must go somewhere when pressing. It can be pressed into the materials of the internal dielectric material, and the resultant spacing between the adjacent layers will be unacceptable. It is recommended to more carefully calculate the layer stack up, taking into account the thickness of the board, thickness of the copper and dielectric layers. Using the board fabricators standard stack up recommendation can serve as a guarantee that the layer stack is correct. Here, usually to overcome the required thickness of the board, as a designer, we used to decrease the thickness of the dielectric material or decrease the thickness of the copper, which will be resulting in the uh, resulting in the abnormal shape of the stack up, which will not be fabricatable by the fabricator. Then in that case, we have to carefully review the stack up, or you can take the inputs from the fabricator. This is the what I required. Based on your inputs, you will be placed in the stack up. Then later, if you adopt that fabricator stack up, so that we can able to overcome these design challenges. Most of the cases, many of the designers, I think, all were joined, maybe or are taking the stack up from the fabricator and then proceeding for the designing, I believe. And another aspect to consider related to dielectric layers that may rise with the number of pre-pack sheets between the layers. Many fabricators recommended as a rule the use of 2 layers of pre-pack to ensure the quality compression. However, not everyone follows the recommendations and may deviate from them by using 1 or 3 layers. In this situation, you may be offered an opportunity to adjust the layer stack up, choosing from the existing range of materials that provide the parameters you need. Designers want to be sure to study the requirements for the layer stack up and, if possible, use non-good layer stacks either from within your organization or from your pairboard fabricator. A manufacturer can offer to change the thickness or types of dielectrics using the layer stack-up. If they cannot guarantee that the transmission line will meet the requirements with the layer stack-up that the designer initially specified, for example, if the designer requires the impedance control trace and the stack-up does not specify the proper materials or does not take into account aspects such as pre-pack shrinkage, the proper thickness of the copper, or edge back consideration, the fabricator may determine that they cannot be assured the proper impedance, and they may offer suggestions on changes to be made in order to ensure that specifications are met. The total thickness of the layer stack up may prevent thicker boards with small wire diameters from being reliably fabricated. This because the ratio of the depth of the hole to the diameter of the hole is exceeded. The typical maximum ratio is 10 to 1, and if this is exceeded, problems may arise. This situation typically occurs in the board with complex HDI requirements. It's a good idea to pay close attention to this ratio during the design. Blind wires are especially sensitive to this depth to diameter ratio. Every designer has likely heard it's always recommended to design a layer stack up that is asymmetrical relative to the middle plane. Deviating from this increase the changes of the board wrappage that will shape. In this situation, the fabricator may give designers input on the layer stack up intended to prevent the board wrappage. However, there is an instance where asymmetrical layer stack ups are feasible. For example, when heterogeneous materials are used, such as plain fiberglass is combined with a high frequency material like rogers. Additionally, sometimes inner layers are heat dissipated by copper with increased thickness. These are special cases we should consider and analyzed accordingly. Now, let us move on to the second subsection. When can a manufacturer uh, proposes a routing adjustment? This often occurs when the clearance between the trays of the same net are so small that the fabricator cannot guarantee the proper production. In this case, such a clearance must be either be filled with the copper or increased. Of course, any of the changes would require approval from the designer. This example considers the situations where the trace dimensions do not result in the current transmission line impedance for a given stack up. However, in this instance, it is the fabricator that is proposing a change to the route. Typically, the trace width of the signal of the single ended signals along with the spacing in the case of differential pair. RTM Designer has two options for working with unconnected pads. One has a special function during the work, the placement and routing. The other as a setting when the generating the Gerber files. The first one is used to leverage during the routing. Removing unconnected pads provides more space for the routing. The second one usually deletes remaining unconnected pads by default when exporting the files. Manufacturers generally prefer not to use extra pads because they increase the wear of the drill. If for some reason you purposely keep unused pads and put them in a Gerber files, you may want to mention this when ordering the bare boards from your fabricator. After all, the manufacturer can just a part of typical preparation process, remove the pads that are not even mentioned. In order to improve the balance of copper in the board layers, the fabricator can add their own non-functional copper with your approval, but no one knows exactly how this copper will affect the performance of the board once the board is populated with components. You don't want to wait for corrections from the fabricator, balance out the copper yourself before releasing to the fabricator. And finally, the last point that I would like to mention is so-called antenna. There are traces that find their way into design that are not connected to anything or at a other ends, which will act as an antenna. Now let us discuss about the how we can control your design data. If the fabricator provides us with the Gerber files that they have updated with the adjustments, we proceed. Even for a simple board, comparing a set of production files manually is a serious task, or for complex board, it is essentially impossible. This is why Alchem provides a special Gerber compare capabilities. It's available as one of the tools in the Alchem PCB workspace. And now I will demonstrate how it can be used, how we can able to compare the different reviews of the Gerber, or if you get a modified Gerber from your fabricator, how we can use that Gerber and how we can compare with the existing Gerber which was released into the RTM 365 from RTM Designer. We'll just see now. Yes, I have opened RTM Designer. The current version of RTM is 22.4.2. And now here I have a project which I have successfully uploaded to the cloud, and I just making this in sync with the cloud workspace. This is the my workspace where I have uploaded my project file to the cloud. Now I want to showcase you how the Gerber can be compared and viewed in the RTP file. Just right click on the project name, just show in web browser. Automatically, the default browser will get open. Yes, it will directly open the project. If you are not signed in with your RTM live credentials in the browser, it will ask you to sign in. You can see here, it completely opened the project, which is uploaded to the RTM workspace. It will be showing here. We have got the schematics for the PCB, active bomb, net information, and the bill of material. And if you go to the releases, it will showcase you the what releases has been done for this particular Gerber. You can see with the timestamp and the date. You can see we have got multiple releases on January 20, and followed by January 21st, we have one release, and April 5 today, maybe April 5 last month, we have a release. It means we have got multiple releases. Here in the RTM 365, we can able to easily compare with this any revision if you want. If you want to see the what is the Gerber and what the data available, just click on open. It will automatically open a separate browser. You can able to see the all your Gerber information here, the release information, and what is the file size, number of layers, and wire count, and what are the power signals, and the type of the project, and all of the components we have. Everything detailed it will be showing here. And if you go here, the Gerber, you can able to see the Gerber files. You can able to click on this particular Gerber file, and you can able to review the Gerber file inside the Alt-N65. You can able to go here. You can able to switch off the all the layers, and you can able to cross verify layer by layer by enabling and disabling each layer. Suppose I found only mid layer one, I can able to enable only mid layer and disable rest all, so that I can quickly review the Gerber. I want to see only the silk screen. I can just only enable the silk screen. I can able to see are there any deviations with respect to the PCB in the Gerber. I can able to review without having a dedicated Gerber viewing tool. I can directly review the same inside the Untitled 55. And if you want to send this information to a fabricator, just click on this send to manufacturer. Here you can see this is the fabrication data, which includes Gerber and NCT file. And we have got assembly information. This is the without variant and this is with variant. If you don't want to include, you can just delete this option. You can enter the email of your fabricator and just click on send. From Untitled itself, he will be getting directly the data. You don't need to install any software. You can directly open the in the browser and you can review the Gerber, and if you want, you can able to comment the same. And also we have an option, to compare with any version of the Gerber which was previously released. Or if you received a file from a fabricator after the modification, if you want to compare, just click on the files and you can just drag or drop and you can select and you can able to do the comparison. But due to some technical issues, that feature is not working. But I just show you how you can the Gerber feature will work with respect to the version 4. I would like to compare with the version 2 or version 1. I have to see what is the changes with respect to version 2. If I want to know, just click on the Fabricator version 4 with version 2. You can see here the red color denotes Fabricator version 2, and this is version 4. And when you click on compare, you can see where and all it has found the changes it is displaying. It has found 18 changes on the this particular project, and there are a few changes in the middle, bottom, top shoulder, top overlay. There are changes it has found with respect to the fabrication version 2 and with respect to fabrication version 4. To click on this particular location to highlight the location, there is a some in version 2 the component is here. Now in version 4 this is slightly pushed towards left side. And here also if you see here in the previous version the capacity is here in the fabric version 2, and when the 4 is being pushed close to this capacitor. Like this you can do quickly see here. This is the where the modification of the component found. Like this you can to easily you can see there is a major change inside this. You can see here it's been did, and you can also see here there is some change in the copper core as well. Okay, you can see here there is some copper has been removed in the version 4 with respect to the version 2, maybe due to some clearance issues. Maybe you might have removed the copper in the version 4, that but in the version 2 the copper is there. Like this you can now easily do the comparison. And also we have a option where you can able to do the doing the measurement as well. Okay, this enables you to quickly review your Gerber with respect to the previous version, and also with respect to the files which are received from the your fabrication. This is all about the how we can compare your Gerber with the previous version with the file received from the fabricator by using R1055. And just repeating again, here there is no need of any building tool required. Just you can directly open directly inside the R1055 and you can able to view the Gerber and compare the Gerber. Okay, this is all about the Gerber comparison feature available inside the Altium 65. Yes,